Hello, everyone. In this video, I'm going to demonstrate how we can do linear and quadratic regression using the TI-Nspire and Desmos. We're going to use pretty small data tables to show it so that we can hopefully not have too long of a video, but I do want to give you multiple examples. All right, so here's number one. Marcus saves money every week. Table below shows how much he has saved M after W weeks. So our independent variable, our X variable, is going to be weeks. Our dependent variable, money, is our Y variable. And then it says to create a linear model for the data, and then using the model, predict how much money Marcus will have saved after 20 weeks. And then using your model, predict how many weeks Marcus will need to save to have $400. All right, so we're going to go ahead and do the Nspire first. So from your home screen in the Nspire, add a new document. So that's choice one. And then we want to add lists and spreadsheets. So pretty much a go-to anytime you have a table of data. And in lists and spreadsheets, it's really important that we name our columns. So you can name your X or your Y variable, or you could type out weeks or money, or just W or M, like it's in the worksheet. It doesn't matter, but do remember what you name them. I'm just going to go ahead and use W and M. So that matches the sheet that we've got. And I'm just going to quickly enter our data. So our weeks are 0, 1, 2, 3, 4, and 5. And then now for our money. So we get 1245, 38, 60, 63, 88, 86, 90, 115.26, and then 137.33. All right. We can take really quickly a quick glance at our first and second differences, right? Just to verify that this really is a linear relationship or should be a linear relationship. So first differences, we're just taking the difference between our Y values. So that's our money. So I'm going to take the 3860 minus the 1245, and then the 6388 minus the 3860. And we can do that because we're in a spreadsheet with formulas. So I can just refer to cell names. So in this one, I could say that this cell is going to equal our column B, row 2. So that's B2 minus our column B, row 1. So minus row 1. And then I can take this formula and fill it all the way down. And to do that, we're going to do menu, data, and do fill. And I can kind of highlight all the way down, and it will update for the rows as we go down. So here's a look at our first differences. It looks like they kind of are hovering from the low 20s to the mid 20s. So it seems, I don't see a specific trend going up or down. So we go down a little bit, then go back up, and then go down. So then for our second differences, we're going to go ahead and now find the differences between our first difference. So I'm now referring to column C. So I'm going to have this equal RC2, minus RC1. And again, I'll fill that down. So menu, data, fill. And looking at this, so we start with negative 0.87. It goes down a little bit to negative 2.26. And it jumps up to 5.34. And then down to negative 6.29. So if I was kind of looking at the average of this, it really does kind of average out to 0, which is going to suggest that the first differences are more of the constant values. So we are going to go with linear for sure on this one, but we can take a look at what the data looks like. We're going to go ahead and graph it. So to link a graph to our list and spreadsheet, we're going to hit the control button and then dock, and we're going to say add graph, which is choice 2. So once we're into our graph, we can go into menu and graph entry edit, choice 3. And then choice 6, which is our scatter plot. And then you just have to tell it what to look at for your data. So in in my column, I named it W and M for X and Y. So I'm going to go ahead and tell it the X is the W and the M is our what we want for Y. You need to put your column names in there. And we hit enter. And I don't see anything yet. It did graph it. It's just because it's out of my view. So I need to zoom in. So I'm going to do menu, window, zoom, which is choice 4. And I like to go to zoom fit first to see what the calculator does. So we're going to zoom in. And then the calculator typically zooms in too close for my liking, but a lot of people like it this way. I'm just going to go ahead and back it out once. So menu, window zoom, and I'm going to zoom out and just click once, and then I can escape out of my zoom. So here's our scatter plot of the data. It does look pretty nice and straight, nice and linear. So that's a good indication and sign. So we can go ahead and do our linear regression. So we're going to go back to our list and spreadsheet. So we're going to go back to that very first tab. And I like to leave kind of a blank column and then click over just to make sure it's not going to overwrite any of my data. So you're just going to click into an empty cell. And I'm going to do menu. And then for regression is a statistical technique. So we're going to do choice 4, statistics. And then choice 1, stat calculations. And then notice here we've got 2 choices for linear regression. So 3 and 4. MX plus B is the format that we've been working on. So we're going to go ahead and do that format. So linear regression, MX plus B. And then just like our scatter plot, we have to tell it what data to look at for X and Y. So X, I called W, and Y, I called M. You would enter whatever you named your columns. And then I'm going to say OK. And it gives us our output. So it tells us that we did linear regression, MX plus B format. Then it gives us the equation it's using. So we get M times X plus B. Right, so that M is our slope, because it's the coefficient of X. It's our rate of change. And B is our intercept. So then it gives us our parameters for M and B. So we have a slope of 25.0686. I'm going to go ahead and round that to 25.07. Our B value, our intercept is 13.0652. I'm going to go ahead and round that to 13.07. And then it gives us a couple measures down below, R squared and an R value. So the R squared is kind of like a goodness of fit measure. Tells you how well your model really is fitting the data. So 99% is pretty strong, pretty good. R is our correlation coefficient. So it tells you how closely correlated your X and Y variable are. So again, this is pretty strong. So let's go ahead and enter our model. I'm going to go ahead and jump back to here. So the equation for our model, when we create a linear model for the data, our Y value up here for money is M. So I'm just going to say M equals. And then we put our slope. So that was 25.07. And that's times our X variable, which is W. Right? And then plus our intercept, so plus 1307. So that is basically our model right there. M equals 25.07 W plus 1307. Now to use it for the predictions, we're going to go ahead and graph our model. So if you go back over to the graph, to add the model, we're going to do menu, graph entry, edit again, because we're going to add something. But instead of the scatter plot where we're graphing our data, now we want to graph a function. So I'm going to select function. And notice it initially pops up as F2 of X. There is actually an F1 of there. And if you scroll up, you can see it. And if you notice, it actually inputted all the parameters for the regression in here already. So you don't have to retype it. All you have to do is scroll up to it and then hit enter, and it will graph that line. So now we can use this line or our model to answer those questions. So the first one was predict how much money Marcus will have saved after 20 weeks. So it gives us 20 weeks. Weeks was our X variable. And if you can't quite remember, when we did the scatter plot, it does tell us our column names. So weeks, the W is on the X coordinate side. So we want to find where on this graph X equals 20 and then find out what Y is in that spot. So there's a couple ways that you can do this. You can do menu, trace, graph trace, and then you would use these little side arrows to move up and forth. Now, right now I'm on the scatter plot because it's just jumping from point to point. But if you use the up or down arrows, that will switch over to the line. So I'm going to switch to the line, and now I can go through the line. And what I want to do is get to the point where X equals 20. You can jump straight there. So I can just type 20 straight in and hit enter, and it will jump and tell us that, okay, that's Y is 514. So basically $514 at 20 weeks. If you want to be a little more exact, you could look at a table of values. So you could hit menu, table. I mean, you can do our split screen table, and again, scroll down to where we see X equals 20, and it gives us some little bit more specific. So $514.44. So we can go ahead and write that in. Whether you want to do just 514 and be more specific and do the 44 cents is up to you. So I got $514.44. If you wanted to be perfectly exact, you would put in 20 for this W up in your model and solve for M and calculate out what you get. All right. So second question, using your model, predict how many weeks Marcus will need to save to have $400. So now they're giving us money. Now they're giving us the Y variable. So you could put $400 in for that M and solve for W to be exact. Or we could use our graph. I'm going to go ahead and close out the table. So menu, table, remove table. So you could kind of scroll and try to find the closest value, or you could go back to your trace and try to get as close to Y equals 400 as we can. The problem with the Nspire is you can't do exactly jump to exact Y values like you can X values. So you can see I'm kind of hovering between 399 and 402 on my graph trace. If I wanted to do a little bit more specific, what I could do is add another line where Y equals 400. And I'm going to go ahead and do that. So I'm going to say menu, graph entry, edit, and a function, and Y equals 400. And there it graphs that line. And then I can look at the intersection. So if you hit menu, and then we want to analyze graph, and I want to look at the intersection. So I'm going to choose choice 4, intersection. And then you just have to define your area. So you kind of drag this line to the left of where you want to look, and then drag it past to the right. And here it finds an intersection. I'm going to move this up. So you can see that for $400, we've got 15.4 weeks. So 15.4 weeks. All right. So that was our first linear regression. Let's go ahead and jump over and show what that looks like on Desmos. So I'm going to go ahead and go to Desmos.com and go into the graphing calculator. Now to add data to Desmos, you would hit this little plus sign that says add item, and we want to add a table. So again, I'm going to put in my X values. And then my Y values. All right, and then kind of the zoom fit on Desmos is this little magnifying glass over here. So we can hit that and look at our scatter plot. Now for regression on Desmos, it's actually a little bit simpler. Is you pretty much type in the equation format that you want. We want to do linear, so the linear form that we are using is slope-intercept form. So we're doing Y equals mx plus b. Now when we want Desmos to do regression, it's pretty simple conversion. So this equal sign is actually just going to come out, and it's going to be the tilde. So the little tilde sign on a keyboard is kind of next to the number 1. You do have to hit the shift key. On Desmos, if you go into the Desmos keyboard and your ABC tab is kind of between the B and the N, like underneath them. So that's your tilde down there. So we would change equals to tilde, and that's actually kind of giving it the code that we want it to do regression. But then you have to refer to your data. So if you look up at your data table, the X values are titled X1 and the Y values are titled Y1. So we need to put those numbers on the Y's and the X's. So we get Y1 tilde M X1 plus B, and then it will draw your line and it will give you your parameters. So again, 25.0686 and 13.0652. And then from here to run the same predictions, Desmos doesn't really have a graph trace option, so we would have to create intersections for linear. So if we were to predict after 20 weeks how much money is going to have, 20 weeks is our X variable, or weeks is our X variable. So we would say X equals 20. And then I have to zoom out a little bit so I can see that line. So you can see that X equals 20, and we would look at our intersection. So where X equals 20, we get y equals 514 and 44 cents. And then, of course, to find the other prediction where how many weeks does he have to save for $400? $400 is a y value, so we say y equals 400. And look where that intersects on our graph as well. So that intersection, and it tells us that it's even more specific than the Nspire, but it tells us that 15.435 weeks. So that would be using Desmos. All right. Let's look at number 2. It says, Linda hits a tennis ball as hard as she can straight up into the air. Table below shows the height h of the ball in meters after s seconds. So our independent variable, our x variable, is going to be seconds, which we'll designate as s, and our dependent variable is going to be height, which we'll designate as an h. And so now it's asking us to use a quadratic model for the data, and then we will predict the maximum height of the ball, the time it takes for the ball to reach that maximum height, and how many seconds it will take for the ball to hit the ground. So I'm going to go back to the Nspire. I'm going to go back to the homepage and create a new document. And I'm not going to save changes from before so that there isn't a way that I'm getting confused between the two of them. And I'm going to add my listen spreadsheet. And so we were going to graph seconds as our x variable and height as our y variable. And I'm going to go ahead and put in that data. So 0, 1, 2, 3, and 4. And then we have our y variable, so 2 meters, 28.2 meters, 40.8 meters, 36.8 meters, and 4.2 meters. All right. Just a quick look at our first and second differences, because it did tell us to do quadratic, but we do kind of want to verify that that sounds about right. So we'll do equals B2 minus B1, and then again we'll do menu data fill. And so this is a very, very, very solid trend, right? 26.2, 12.6, -4, -32.6. So we are steadily going down, which is going to give our first clue that probably is not going to be linear at all. So let's go ahead and do our second differences. That's going to be equal C2 minus C1, and then we'll fill that. So this one, we're still not really hovering around 0. It wouldn't average out to that. And there's still kind of a downward trend, but it's a little closer in, I guess, than the other one. So maybe even third differences might even be better on that. But we'll stop there just because it said to do quadratic. It could just be a function of having so few data points. So let's go ahead and graph it. So we'll link a graph. So hit Control Doc. And then we're going to add a graph, linking it to our spreadsheet. And to do our data, we need to do graph entry edit and put in a scatter plot. And so I titled my x values S, and I titled the y values H. So I'm going to go ahead and tell Desmos that that's where it's going to pull its data. And then I'm going to zoom fit. So I do menu, window zoom, zoom fit. And then again, I'm going to back out one just because I like to see a little bit further out than where the calculator goes. All right, so it does go up and come back down. So yeah, we are going to this definitely does kind of look more like a parabola. So we will graph quadratic. So we're going to go ahead and run quadratic regression. On the Nspire, it's going to work pretty much the exact same. I'm going to click open into an empty cell, leaving some space so I know I'm not overriding anything. And we're going to go back to menu, statistics, stat calculations. This time we're going to do quadratic regression. So we're not going to do linear. We're going to do quadratic. And I'm going to hit that and then give it where to look for the data. So we want it to use the S for seconds as our X variable. We want it to use H for height for our Y variables. And then hit OK. All right, so underneath our output here, it tells us the format that it's using. So it's using the ax squared plus bx plus c. So it's using kind of the standard form or the general form of a quadratic equation. It's not using vertex form. It's not using factored form. And then it gives us our parameters, a, b, and c. So the coefficient on the x squared term is going to be the negative 9 point, I guess that would be 59 if we round it. B is going to be 39.64. and C is going to be 0.63, so rounding to the nearest hundredth. And then if we look down, we do have an R squared value. It's still pretty good, right, of 0.98, so that's still pretty strong. And then this one does actually give us our residuals so that we could somewhat look at these to determine if maybe we needed to look for a different model instead. But we're going to go ahead and graph quadratic on this. So let's go ahead and graph it. We'll go back to our graph. We want to do menu, graph, entry, edit, and then this time we're going to add a function. And notice, again, it's back up as F2, so that means we can scroll up. There's an F1 somewhere. And if we look at that F1, just like it did before, it inputted all the parameters of our model already, so we can just hit enter. And it graphs out our parabola. So now let's go ahead and record our model. All right, so I've got our y value is h, so we get h equals negative 9.59, and then it's going to be x squared, but we're using s for our x variable. So I'm going to do s squared, and then I'm going to superscript that. And then we will add our beaver coefficient, so 39.64, and that will be times s to the power of 1, and then our c value, so 0.63. And that is our model. So now we can go ahead and do the predictions. So it wants us to predict the maximum height of the ball, so the highest that this ball will go. So again, you could do menu, trace, graph trace, and try to figure out where the highest is. But to be more, a little bit more specific, what you want to do is go into this analyze graph, and we're going to look for the maximum point. So I'm going to hit maximum. And then again, you want to define your area. So you just kind of highlight a little bit to the left and drag it past to the right. It did find a maximum at the point 2.07, 41.6. And so X is our seconds. So this is at 2.07 seconds, right? We reached 41.6 meters. So we can go ahead and answer our questions that way. So the maximum height of the ball is 41.6 meters. And how long it took to get there was 2.07 seconds. All right, then it asks us another question. Using your model, predict how many seconds it will take for the ball to hit the ground. So coming back, we're talking about it being launched up and then coming back and hitting the ground where height is going to be 0. So we're looking for one of the roots, one of the x-intercepts now. So if you go back to menu and analyze graph, it calls the root zeros. So we're going to look for a 0. And again, we're going to define our area and drag that to where we can read it. And so it tells us that it's back on the ground again at 4.15 seconds. All right, so let's go ahead and see what quadratic looks like in Desmos. I'm going to jump over to Desmos and close out everything that we did to our other problem. I'm going to add a new table. Sometimes when you've done multiple ones, sometimes these numbers appear as a 2. If they do, like if I was to add a new table, notice they come up as x2, y2. When you run regression, you want to make sure you are referring to the correct list of data. So sometimes instead of 1s, you want to be adding 2s on your variables. So just kind of something to look at. All right, let's go ahead and put in our data on Desmos. So our x values are 0, 1, 2, 3, and 4. And then our y values, we have 2, 28.2, and then 40.8, and 36.8, and 4.2. Okay, I'm going to go ahead and zoom fit that and just back out a little bit. So here we see our data. Running regression is going to work the same way. So you say what kind of equation that you want. I want to be y equals ax squared plus bx plus c. And then for regression, we change the equal sign to a tilde. And then my data is x1 and y1. So on the y, I have to say y1. And then I've got two x's that I need to add that 1 on. And once I do that, it graphs out my model. So from here, it's a little bit easier because once you click this, Desmos kind of predicts important features of this graph. So right away, it shows the vertex, the maximum point. And it's a little more specific again. So 2.068 and then 41.616. And then it'll hit the ground again in 4.151 seconds. So just a little bit more specific. It's taking the rounding out just a bit further. All right. Let's look at number 3. It says Abdul records how much force it takes to accelerate a 25,000 kilogram train. The table below shows the amount of acceleration A in meters per second squared and the force F in newtons it requires to attain that acceleration. So here we have acceleration is our independent variable, our X variable, and then force is our Y variable. So we want to create a linear model for the data. And then we've got, it looks like a couple different predictions. So predict how much force Abdul will need to accelerate by 7 meters per second squared and predict how much the train will accelerate with 200,000 newtons of force. So we're going to go ahead and go back to the Nspire first. So I'm going to start a new document and I'm not going to save any changes. And I'm going to add my listen spreadsheet. So acceleration, we're calling A, it's our X value, and Y is our force. We're going to call that F. And then I'm going to go ahead and enter the data. So I've got 0, 1, 2, 3, 4, and 5. And then 0, 24,800, 51,370, 73,290, 102,300. And then 122,980. All right. So I am going to go ahead and do first and second differences. So this is going to equal B2 minus B1. And then we will data fill all of that down. So it looks like on all of our differences, first differences, so we get 24,000, 26,000, 22, 29, 20. So we are kind of going up and down. We're not really seeing a distinct trend. So, and we're kind of hovering somewhere in the 20s. So let's go ahead and run our second differences. So equal C2 minus C1, and we'll data fill it down. All right, so 1,000, then we jump to negative, and then back up to 7, and then back down to negative. So this is definitely jumping over the 0 line. So, or back and forth over the 0 line. So yeah, it looks like first differences are what we're going to go through, and we're going to go ahead and do a linear regression. But let's go ahead and plot it first, just to make sure it does indeed look linear. So we're going to add a graph. So do Control Doc, and then we will add a graph. And we're going to enter a scatter plot. So menu, graph entry, edit, and then choice 6 is scatter plot. And then we named our X values A and our Y values F. So I'm going to go ahead and enter. So I can see 1 point, but that's it. So I'm definitely going to do a zoom fit. So zoom that out. That very much so does look pretty linear. I'll back out just once on the zoom. All right. So yeah, definitely we will stick with linear. And then let's go ahead and run the regression. So back on our listen spreadsheets, we're going to find a open space to click in, and we'll do menu, statistics, stat calculations, and we want our linear regression mx plus b. And we have to identify our data. So we said our X values, we named A, and our Y values, we named F. And so here's our slope, 24,837.7. Our B value, our intercept, 362.381. We have a super high R squared value. Pretty strong correlation as well. So let's go ahead and put this graph. Oh, actually, I'm going to write down the parameters so we can write our model. So let me just write it down really quick. All right, so our slope M is 24,837.7, and our intercept is 362.381. So we'll just say 0.38, rounding to the nearest hundredth. All right, so go ahead and write out our model. So our Y value is F, so we're going to get F equals, and then our slope, 24,837.7. And that's going to be times our X value, which is A. And then plus our intercept, 362.38. All right, so there's our model. So let's go ahead and graph it. So we go back to our graph. Let's just tab over to our graph. And then we're going to enter a function. So menu, graph entry edit. We want to add a function. Again, it comes up on F2. So that means there is already an F1. We can scroll back up to the F1 and it auto put our function. So we just hit enter and it graphs it. Now notice because our numbers are pretty big, it goes into scientific notation. So this is 2.48E4, right? This is telling us that this is 2.48 times 10 to the power of 4. So it's just putting it in scientific notation. So when we run our predictions, it says predict how much force Abdul will need to accelerate the train by 7 meters per second squared. So if we want to do this by a graph trace, we do trace, graph trace. We want to go to where x equals 7. Oops, I need to be on my line. So we want to go to where x equals 7. And that is in scientific notation. So it says 1.74 E plus 5. So that's 1.74 times 10 to the power of 5. So really we are multiplying 1.74 by 100,000, right? A 1 with 5 zeros on it. So we get 174,000. Or we could open our table. So we could do menu, table, split screen table, go down to where we see 7, and that kind of gives us a little bit more information. So we have 174,226. So we can go ahead and enter that. So we've got 174,226, and these were newtons. All right, the next question says, using your model, predict how much the train will accelerate with 200,000 newtons of force. So newtons is a Y value. So when we come back to our Nspire, we can go ahead and close out our table. So menu, table, remove. And then I can graph my Y equals line. So I'm going to have menu, graph entry, edit. I'm going to add a function. So F2 of X is now going to equal 200,000. And then I'm going to zoom out once more just so that I can see that intersection a little better. So when I want to find out that intersection, we would do menu, analyze graph, and then choose intersection. So I go to the left, click it, drag it, take it to the right. And again, it's giving it to us in scientific notation. So they're just saying 2e plus 5. So that's basically 200,000, right? 2 times a 1 followed by 5 zeros. So that's kind of a rough estimate, but we can say 200,000. Again, to be exact, you could put it in and solve in our actual model. Oh, I guess that's what we gave. So 8.4, I guess we're looking for seconds. Sorry, I lost track of where I was. Okay, so 8.4 seconds is where we reached 200,000, right? 8.04 seconds. That's our X value. Okay, 8.04 All right, so let's see how this one just differs a little bit, maybe by Desmos. So we're going to add a table, put our data back in, 0, 1, 2, 3, 4, 5, and then 0, 24. Both the Nspire and Desmos do not like commas, so make sure you're not entering commas. We can zoom fit it and then run our regression. So we want linear. So I do want to do the y equals mx plus b, but I want to refer to my data. So I'm going to say y1 because that's going to say, see, it automatically pulls up, hey, I've got the 6-element list here. And instead of the equals, I want the tilde. So I'm going to do y1 tilde. And then we get mx1 plus b. And so here it gives our parameters. So our 24,837.7 and our 362.381. So pretty much the same model that the TI-Nspire gave us. So for our predictions on Desmos, right, we just do our x equals and our y equals equations. So the first question, they want to know how much force is needed to accelerate 7 meters per second squared. So they are giving us acceleration, which is an x value. So we do x equals 7, and we look at its intersection. And so we get 174,226, and then technically 0.381. So again, it's just maybe a little more information than what the Nspire gave us, but pretty much in agreement. And then our second question, how much the train will accelerate with 200,000 newtons of force. So now this is y because 200,000 newtons is a y variable value. So we have 200,000. Again, we're going to look at where our intersection is between our model and that line. And so it tells us that it's 8.038. So I think in the Nspire said 8.04, but the Desmos is telling us 8.038. So still pretty close enough for our predictions. All right, we'll go ahead and do one more. I know it's a pretty long video, but just so you can see it a couple more. So let's look at number 4. Paula records the total profits for SNAS gadgets based on their selling price. Table below shows the total profits T according to selling price P. So we're got some choices of $5, $6, $7, $8, and $9 that we're going to sell a SNAS gadget for. And then the profit made at each price is listed below. So on the Nspire, I'm going to go back home and start a new document. I'm not going to save any changes. Add lists and spreadsheets. All right, so our price was actually our independent variable, our X value. And then the profit made from that was our total profit. We're going to call T is our Y value. So let's go ahead and enter it. So we can do $5, $6, $7, $8, or $9. And then we will add in, so 71,200, 223,600, 346,180. 4, 4, 5, 600, and 510, 400. All right, really quickly, I will run first and second differences just to see what we're looking at. So for first differences, that's going to equal B2 minus B1, and then we are going to take data and fill them all the way down. And so my first difference is I have 152,000 and then 122 and then 99 and then 64. So I'm pretty much steadily going down. I am seeing a pretty significant downwards trend, so that may not be our best bet. So let's go ahead and look at our second differences. So now this one's going to equal C2 minus C1, and I will data fill it all the way down. So 29,000 to negative 23,000, so a little bit upwards, but then we drop down, so it is kind of bouncing back and forth. whether it's going up or down. So that definitely looks like a better fit. So let's go ahead and see what this looks like on the graph. So we link a graph, control, doc, and then we want to add a graph. And then we're just going to do graph the data right now because we haven't done regression yet. So we're going to do menu, graph entry, edit. We want to graph a scatter plot for our data. And we called our X values S and our Y values H. Oops, maybe I didn't call them that. We called them P and T, my bad. P and T. I was looking at the previous problem. All right, so there we go. And then let's go ahead and zoom fit. So menu, window zoom, and then choice A, zoom fit. And I'm going to back it out just a little bit. All right, so I can kind of see a little bit of a curve. So I see why maybe it looks like maybe it's more quadratic. I can also see why somebody might pick linear for this, but it does seem to sort of be curving it over a bit. So that looks like quadratic's a pretty good choice. Let's go ahead and run quadratic regression. So we're going to come back to an empty cell. So we're going to do leave us some space, and we'll go menu statistics, and then stat calculations. And this time we want quadratic regression because we like the idea of second differences better. And so for X, we had P, and for Y, we called those T. And we'll say OK. So here are our results. So we've got our A value, our A parameter, negative 14,168.6. B is 308,400. And then C is negative 1.1168. All right, so go ahead and enter this. So for our quadratic model, so we have Y equals, but we're calling Y T. So I'm going to get T equals. And then my A coefficient, so that was negative 14,168.6. And that's going to be attached to our X squared, but we're calling XP. So we'll get P squared. Go ahead and that is a superscript. And then plus our B value, so that's plus 308,400. That's going to be just times P to the power of 1. And then plus our C value. C value is negative, so we will get minus 1.12. We're going to round that. So there is our model. So again, to be exact on predictions, we would enter it, what we have into the variable that we're given and calculate it out to see what we get for the other one, but we can do rough predictions off of the graphs. So we'll go ahead and graph it. So using your model, predict which price creates maximum profits. So going back to our graph, let's go ahead and graph it out. So we have menu, graph entry, edit, function. We did run the regression in a linked spreadsheet, so we should be able to find it. There it is. We scroll up to F1, and there is our parabola. I'm going to zoom out again just because I don't think I can see the vertex yet. So no zoom out. I'll zoom out again so I can see the roots as well. Okay. So then I can escape. All right. So in order to find our vertex, we're going to look for our maximum point. So I do menu, analyze graph. And I'm going to search for the maximum. So again, I'm going to draw, click on towards the left of it and drag it over to the right. And so here is our maximum point. So it looks like $10.90 is going to be our highest, or the price that creates the maximum profit. So we have $10.90. And then it's going to create 5.61 times 10 to the power of 5 in profits. So that's going to be $561,000 worth of profit. All right, so we have $10.90 is our max with $561,000 worth of profit. So I'm going to go ahead and write those down. So predict which price, and the price was $10.90. That was our X value for our maximum point. And at $10.90, we predict that we will get $561,000 worth of profit. All right, and then it says, using your model, predict at which price level SNAS gadgets will lose money for the company. So why is our profit? So the point where profits become negative, right? That's the point at which we're losing money. And I've got actually two real roots because I've got two positive X roots. So I'm going to look at both of them. So I'm going to do menu, analyze graph, and look for 0. So on the left side, we get 4.590. So that means anything under $4.59 will lose money. So I'll say under $4.59, excuse me, under $4.59. And then I've got the other root as well. So I'm going to go back, analyze graph, and do 0. And then I'll highlight the other one. And then it looks like if we charge more than $17.20, we will start losing money as well. So our profits will go negative. So there are actually two real answers to this one. I'm going to go ahead and just type it down below because we're going to need more space. So under $4.59. Oops, I missed my 4. $4.59. And over $17.20 is where we will start to lose money. All right, let's go ahead and just quickly run this run through Desmos just to see how it compares. So again, I'm going to add my table and then my data. So we get 5, 6, 7, 8, and 9. And then for the Y values, 71,200. And then 223, 600, 346, 180, 445, 600, 510,400. All right, I'll zoom fit that. Maybe back out a little bit. All right, so for our regression, again, we'll all start with Y1 tilde, right? And again, if there are 2's on your table, you would need 2 instead of Y1, but that's where we go. Then we want to do A times X1 squared, so A X1 squared, and then we want plus B times X1, and then plus C. And it will give us our parameters, kind of the exact same model that the Nspire gave us, right? Negative 14,168.6, x squared plus 308,400 x, and then it gives us a much smaller C value. Actually, I bet maybe I missed the extremely small C value. I must have missed that in the Nspire. I'm going to come back and take a look. Oh, yeah, there it is. If you see it, it's negative 0.112 times e to the power of 6. So we will have to go back to our thing and change that. So this is actually minus 112, but to the power of 6. So I can move that decimal point 6 places over. So there's 1, 2, 3, 4, 5, 6. There we go. All right. And then again, we can just kind of touch the graph on here and get our maximum. So it does give us a little bit more specific, where instead of 561,000, gives us kind of more the exact $561,389.15. And it actually, instead of rounding to 10.9 or 1090, it says that really $10.88 is our maximum. So a little bit more specific, closer to if you had actually inputted it into the equation and solved. And then for losing money, we want our 2 roots. So we would just touch the roots. So that's giving us at $4.59 roughly, and $17.18. All right, I know this video has been super long. I just wanted you guys to be able to see how we could do this on both the Nspire and on Desmos. Give it some practice. I think for the class I gave you guys have like 2 more that you can practice with, just using the Nspire or using Desmos. All right, guys. I will see you after break.